Hello, it's Scott Manley here, and this is ESAR Aerospace's Spectrum rocket. And as you can guess, last night they finally made their first launch attempt. And, well, the dressing gown tells you everything you need to know. It didn't actually succeed. I was asleep when this happened because I have a sensible sleep schedule, but when I woke up to all sorts of questions about what happened beyond it failed. So yeah, this launch vehicle is launching from the Andoya spaceport up in Norway, and this marks the first orbital launch attempt by a private launch company from European soil. Now, technically, Virgin Galactic launched out of Europe, but that was an air launch and it wasn't successful. And of course, Russia launches out of Plesetsk, which is technically in Europe. But, considering that this company is based in Germany, and Germany is kind of the origin of a lot of modern rocket technology, it's surprising that this is actually the first orbital rocket launch attempt from Europe, for Western Europe. Anyway, yeah, timer counts down to zero. We didn't get any messages from any audio from the control room. Yeah, launch goes vertical right away, and that in itself is a massive success. But as it starts to ascend, you can see that the thrust vectoring on that exhaust is wobbling to the left and the right. This is the rocket trying to steer itself, and it seems to be self-exciting an oscillation somehow. And eventually, it just pitches over. They shut down the engines, and by the way, in the bottom left screen, you can see how long it takes for those engine telemetry things to actually show that the engines were shut down. They cut away to a different camera. There's some audio, there's maybe a bit of camera shaking, but we didn't even get to see where it landed, and that was a mystery for a good amount of time until we got a different bit of video. So this is some drone footage that was captured, and I've sort of zoomed in so we can get a better idea, but this gives us a better context of the launch site. This is sort of looking south towards the launch pad, out over, the North Sea or the Arctic Ocean or whatever. But yeah, again, from this angle, you get to see the launch going up and, again, wobbling on that exhaust. And you can also get an idea of how it's moving with respect to the airstream by these vents that are running across the side. And yeah, again, it pitches over. Now, watch, the rear is actually what flips all the way over and impacts the water first. So it actually comes down and lands in the bay. And there's a bit of a flash. You can actually see like a shockwave heading out. And also watch the debris shooting out and landing in the bay. And given that there's a bunch of cryogenics in this, liquid oxygen and liquid propane, there's probably a lot of ice floating around up here. So that still doesn't give us much. It just shows that the launch infrastructure is largely undamaged by this catastrophic event, and that they should be able to get back up into operation to try their next flight. And a third angle comes from this adventurous fellow who decides to, hike across a frozen Norwegian marsh so that he can get close enough to the launch site to get some decent images. Now, he's a few miles away here, but his angle confirms what we've seen in the other ones. Again, the rocket seems to ascend off the pad at a reasonable speed, and as soon as it starts to clear it, we again see these the changes in the direction of the rocket exhaust. And that's important because it tells us that the rocket engines are gimbaling and trying to steer the rocket. So the rocket, it's not a mechanical failure there, but it loses control. So it looks to me like the guidance is perhaps oversteering, or it is getting incorrect inputs. The inputs they expect are not translating correctly to the output. And so yeah, what else can we figure out from this? So if we rewind to the start of the stream, there's like a whole bunch of B-roll that, is good because it shows us the rocket. This is the Spectrum. So the company is ESAR Aerospace, as I said. That's based in Munich. I think ESAR is the river that runs through Munich. This launch vehicle is 28 meters long, and it's all built of carbon fiber composite. Yes, they use linerless tanks for the propellants. Propellants are propane and liquid oxygen, which has the advantage of being better density than methane and liquid oxygen, but it's a little more expensive, and I think it has higher combustion temperatures. Compared to kerosene, it also is a lot cheaper and has slightly better specific impulse, but it is mildly cryogenic. So you can see 9 engines on here. These are Aquila engines, and they are gas generator cycles. Now, if you know, the other company in Germany is Rocket Factory Augsburg, and they use staged combustion, which is a bit more high-tech, more complicated. This is a simpler system to build, and they also have one engine on the second stage, which has obviously... Oh, here's an interesting point, actually. Some people saw this and thought this might be a roll control thruster assembly, and I had to look at this multiple times, but I think this is just connections from ground service equipment, because you see an angle where it's connected directly in. Yeah, these are, again, 9 engines, and you can see these red covers here that cover up the gas generator exhaust that comes out. So, yeah, the only reason you would have roll control thrusters on this would be if you didn't have thrust vector control here, and since you have 9 engines with 2-axis control, they should have lots of control. But hey, given that we're talking about a loss of control, it's important to establish how this rocket steers during the early flight. So, yeah, there is rolling up to the launch pad on its erector system. There's a base in there. Yeah, they're taking these pins out. They're attaching it to the strong back and raising it vertical. So again, this is one of the more beautiful launch sites in the world, located up inside the Arctic Circle. Definitely a contender for prettiest launch site. It's nice to see the people up next to the rocket, because it gives you a pretty good idea of the scale of the vehicle. This is not a huge launch vehicle. It's designed to only launch about 1 ton into orbit, but that makes it comparable to like Firefly's, small vehicle, the Alpha, and also comparable to Rocket Factory Augsburg's launch vehicle. So yeah, all that full moon and some very pretty northern lights, the Aurora Borealis. Okay, so now if we switch back to the pre-flight footage, again, there's a moment here where we get to see the umbilicals attached to the pad. And yeah, again, this is where some people thought that was a Vernier thruster. No, there's a bunch of umbilicals connected in there, so that's not what's going on. If we skip this forwards, let's try and find there's a view just up inside the launch table there. Okay, so yeah, this is again the view of the rear of the rocket. You can see these gas generator exhausts, and you can see these nozzles. Also note these little vents along the side. That's used for chilling or conditioning the engine by flowing the propellant through the engine just prior to ignition. Then we have ignition, we lose the camera, but then we get to see the rocket actually beginning to lift off. All the umbilicals drop away and it starts to move. So yeah, you can see they're blowing, like they're venting stuff out of the side of the rocket, and that's actually pretty useful for figuring out what way the rocket is moving. Now initially, it does look like all the engines are lit just fine, so I don't think they had an engine failure right away, but that might have contributed. Now, if you watch this frame here, there's a bit where it sort of glitches in. Let's actually bring up the... So zooming in, I thought that I saw a moment. See that? I thought the rocket exhaust shrunk for a second and shot back out. But the more I watch this, the more I think that is just a compression artifact and not actually a real change in the exhaust. I haven't seen any images that suggest that any of the engines failed. If the engines had failed, we would have probably seen it in the on-screen display in the bottom left corner. So I think all the engines are operating fine. So that's not the problem. Okay, so we skip forward to this point, and this is where we've just got a close-up of the rocket. And I'm pausing it here because you can see that the exhaust is not aligned with the direction of the rocket is pointing. So these engine gimbals are working, and they're all working together. That's a sign that the mechanical stuff down here is working just fine. But watch the black markings on the side of the rocket as I start to play it forwards here, right? What you're going to see is that the rocket is very obviously in a roll. And I think that is a roll that's been excited by the guidance system itself, and because the rocket is rolling, it is hard to control. So I think that they somehow self-excited a roll. It could be that they simply lost, they had wires connected back to front, or it could be that simply there was some component of the vehicle motion which they didn't understand, because obviously they've never flown the vehicle before. It's only been in simulations. So exciting some like motion like this, it's entirely possible that's the root cause of this. Okay, so now question I have is, how high did it actually get? And I think the fastest way to figure this out is to measure when it reaches the apex and just time how long it takes to fall back down. And assuming that there's not much in the way of drag, yeah, so there we go. That's the start there, right? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 seconds, right? So, and I can do that almost in my head, right? Because the equation is half a t squared. So t is 10, so that's t squared is 100. That's easy. Half of that is 50. G is about 9.8, so multiply 9.8 by 50, and you get 490 meters. So that's about 500 meters up if there's no drag. The question is, how high is that mountain? I guess I have to go and look to see where that is on the map. So yeah, what we should do is find out how big that mountain was, just for reference, to see if we're roughly the right scale. Here's Andoya. Now where's the spaceport? It's somewhere down around here. Ah, yes, there we go. Andoya Spaceport. Okay, so now, first of all, I think the person that hiked in must have hiked in around this area here. And if I do measure the distance, that is about 1 kilometer from the launch site. That seems totally reasonable. And also, that means that this is maybe a couple of hundred meters that the rocket actually traveled horizontally. Now, we should be able to see, yes, this is the mountain, right? So if we turn around to this angle, that's sort of what people are seeing in the background as a reference, right? Okay. So now, from the photographer's viewpoint, it flew above this mountain. How tall is that mountain? Let's take a look at the terrain layers. Yeah, there we go. So 200, 300 meters, 320, 340. So this is about 350 meters tall at the highest point. And the fact that the rocket appears above it means that that's a not unreasonable estimation. I guess we should take a look to see just how much it appears above the rocket. I wish VLC was better at seeking. There we go. Find that spot. That's it roughly at the highest point. So, like, between these two cloud layers, and if we skip forward a bit, so yeah, 350 meters there, 500 meters there. That's totally roughly consistent. Yeah, so I think about 500 meters is how high this rocket got before it ended up falling back. Now, they just let it fall back. They terminated the engines, obviously. This wasn't an engine failure. They chose to shut down the engines to stop it going, out of control. They didn't have any explosive systems to actually terminate the rocket itself, and thankfully when it fell back down, it didn't end up crashing into the launch pad and causing them a whole lot of other problems to move forwards. But I'm sure it sucked if you were some fish in that bay. So we got one other video showing the launch, and this was from the Andoya spaceport itself, and I think they had a camera round about here somewhere. Yeah, obviously they're showing us how pretty this launch site is. I would love to go someday. It'll probably look a whole lot better when it's in real life rather than 720p video. But yeah, they had a camera somewhere over here, and you can see that it shows the ascent initially. But this also means that it's the closest camera showing the landing, or sorry, the descent. We cut away, and then there it goes, boom, into the water up close. And from this, you can definitely see there's a fireball going on inside there as the fuel and the oxidizer mix and continue to burn. And it, of course, transitions into a thermally driven mushroom cloud, which is basically nature's way of saying that your launch didn't work as expected. And it's a shame. It's obviously historic as being the first attempt at an orbital rocket launch from Europe. And I pointed out, yeah, Germany They were pretty much the first people building big liquid fueled rockets. And somehow, Western Europe has never launched a rocket to orbit. They've been beaten by Asia, Russia, the North America, South America, Africa, Australasia. They've all launched rockets from those continents. Western Europe has not had an orbital rocket launch in all its glorious history. So yeah, I'm glad to see that their launch infrastructure has survived. So that should at least mean that they just have to build a new rocket and solve whatever problems are with this one. I think it's possible that there's a simple algorithm issue that they need to adjust their gains for their steering, or it could be, and this is what I think, maybe they had the roll sensor inverted because the roll seemed to accentuate and build up. But then again, it was already oscillating before there was any roll in the system. So I think this is like a software guidance issue that simply is something that is very hard to simulate. It's really hard to simulate a rocket ascending with fuel that it starts to slosh around, and where you perhaps find that you have new issues with your rocket engines. Pogo oscillations are a real thing, and this is the first time they've flown the vehicle, so it's entirely possible they might have got thruster oscillations that led to the loss of control. Whatever happens, I hope that ESR recovers from this and moves forward, and we get to see a real successful orbital launch from Europe in the coming years. I'm Scott Manley. Fly safe.